So now this is related with the brake rope test, right? Now this problem is based under the brake rope test, right, for a single cylinder engine, right? So now let's quickly see what are the given data, right? Indicated mean effective pressure is given, bow and stroke, like bow diameter and stroke length is given, right? Then calorific value of liquid gas is given, right? So now what is the flow? There is a liquid gas in the flow, right? And then fuel flow rate, the liquid gas consumption is given, okay? Density of liquid gas is given, engine speed is given, effective brake diameter is given, right? And what are the other information that are given? Dead weight on brake is given, spin balance reading is given, right? So these two information are very much important, right? This one, dead weight on brake, right? If the problem is related with the brake rope test, right, then dead weight on brake and this spin balance reading, those two information are very much, right, important, right? Then cooling water flow rate and temperature rise of cooling water, right? Okay, so what is the first thing they are asking? They want us to calculate the mechanical efficiency, right? So before that we should calculate brake power. So I will write the equation: brake power. Brake power equals, right, dead weight on brake. I will write dead weight on brake minus, right, spin balance reading, spin balance reading, right? And next thing is that effective brake radius, right? Dead weight on brake minus spin balance reading multiplied by effective brake radius, right? And then 2 pi n divided by 60, right? What is n there? N is the engine RPM, okay, right? So then equals dead weight 400, spin balance reading is 40. Then what is the effective brake radius? So we know the effective brake diameter, that is 0.9. So effective brake radius will be 0.9 divided by 2, right? Because they are asking power, right? Power means torque into angular velocity, right? Okay, so 400 minus 40, 0.9 divided by 2 times 2 multiplied by pi multiplied by what is the engine RPM? 600. 600 divided by 60, right? So now let's take the calculator and do the simplification, right? Yeah, the answer is 10,178. 10,178.7. So we can consider as 10,179. The answer will come in watts, right? So it will be 10.179 kilowatts, right? What is this now? This is the brake power. Okay, right. So now brake power is calculated, right? Okay, so now I will write that answer here. Brake power equals 10.179 kilowatts. Okay, now next thing, right? I will erase this one, okay? Right. Now I will erase. Next thing, now we need to find the indicated power, right? IP, indicated power, right? So now when you are going to consider an equation, right, and you have to know the meaning also, right? Not only the terms but even the meaning, right? So what is indicated power? That equals, let's write indicated mean effective pressure, right? Okay, indicated mean effective pressure multiplied by stroke length S, right? Let's write ST ROK, stroke length, right? Then cross sectional area, right? Because if you know the bore diameter, you can find what is the cross sectional area. Cross sectional area, okay, and now carefully wait, right? N bar times K, right? N bar times K divided by 60, right? I will again teach you that indicated power equals indicated mean effective pressure multiplied by stroke length, then cross sectional area multiplied by N bar times K. Now here K means number of cylinders, right? What is K? That is actually the number of cylinders, right? And one more thing, right? So now this brake rope test is done for a 4-stroke single cylinder engine, right? For what? That is also an important information, right? Now this brake rope test is done for a 4-stroke single cylinder engine, right? 4-stroke, right? Now carefully focus. Now if it is 4-stroke, right? That is what I want to tell you, right? Now if it is a 4-stroke engine, this N bar, that is why I have purposely written N bar. N bar is N divided by 2. Why N bar is N divided by 2? Because if it is a 4-stroke engine, it is N divided by 2. Now shall we write again? Indicated mean effective pressure. So let's write PI, okay? Stroke length S, right? Then cross sectional area. What is that? Pi d square divided by 4, okay? But be very careful, you have to put in standard units, right? Multiplied by N divided by 2, right? Because why? It is a 4-stroke engine, right? K is 1 by single cylinder engine, and this divided by 60 is a must, right? That is to convert that RPM into radians per second, right? Right. So now, shall we write? Now be very careful. Now you have to put in standard units, right? What is the indicated mean effective pressure? 395. But 395, where is it? Indicated mean effective pressure is 395. It's not newtons, it's kilonewtons, right? I have to tell you that. It's not newtons, it is kilonewtons, right? Right? Earlier I told it is newtons, it's not newtons, it is kilonewtons per meter square, right? So now PI is, now you have to put in standard units, right? So kilonewtons per meter square, so 395 multiplied by 10 to the power 3 newtons per meter squared, okay? Right. Now stroke length. What is the stroke length? Stroke length is what is stroke length? 305 millimeters, right? So 305 millimeters. So divide this by 1000. So now we have stroke length in meters, right? Then cross sectional area pi multiplied by what is the bore diameter? Bore diameter is 165. Okay, no problem. 165 bore diameter whole thing square 165 pi d square divided by 4, then divide this by 10 to the power 6 to convert millimeter squared into meter squared, right? 10 to the power 6. So now that is also okay. Then what is the engine RPM? So that is 600, right? So then 600 divided by 2, then this whole thing divided by 60. Okay. Now K is 1. What is the reason? Because number of, we have only the single cylinder, right? So now let's take the calculator. Now simplifications we have to do, right? 395 10 to the power 3 to 305 divided by 1000 multiplied by pi multiplied by 165 squared divided by 4 divided by 10 to the power 6 multiplied by 600 divided by 2 divided by 60. So the answer, right, if you carefully do the simplifications, right, you are getting the answer 12,880, right? 12,880.26. 12,880.26. Now in watts, right? So then in kilowatts it will be 12.88 kilowatts. Okay. So now what is the indicated power? That is 12.88 kilowatts, right? Now again carefully focus the board, right? Brake power known, indicated power known, right? Okay. Now we can very easily find what is the mechanical efficiency. Now I will erase this, okay? Very easy, right? It's not hard, okay? So what is mechanical efficiency? Mechanical efficiency is brake power divided by indicated power multiplied by 100%. Okay? 10.179 divided by 12.88 into 100%. So use the calculator. What is that? 10.179 divided by 12.88. 79.02, 79.02, or you can say 79%, right? So that is the mechanical efficiency. Now the next thing is indicated thermal efficiency. So what is indicated thermal efficiency? We'll focus that in the next step, right? So mechanical efficiency is known, right? What is that? 79%. Okay. So let's calculate the other part. Next thing, indicated thermal efficiency. Indicated thermal efficiency. Right. So what is indicated thermal efficiency? Indicated thermal efficiency, ITE, that equals indicated power, right? Indicated thermal efficiency means indicated power divided by heat input. So indicated power we already know, right? Now we have to find what is the heat input. So let's find what is heat input, right? What is heat input? So heat input equals, right, fuel flow rate, very simple equation, right? Heat input equals fuel flow rate, right, multiplied by calorific value of the fuel. What is the fuel flow rate actually? Say liquid gas consumption 4.5. Okay, so 4.5 liters per hour. Then what is the calorific value? There 32,300 of kilojoules it is given per 1 liter. Yeah, so no problem, right? Then we can calculate how many kilojoules per hour. What is the heat input in kilojoules per hour, right? Okay, so agree, right? This multiplied by that will give you kilojoules per hour, right? Now we want in kilowatts, right? This is giving the quantity per an hour, right? So now this answer we will again divide by 3600, right? So this answer we will again divide by 3600. So that will give the amount in kilojoules per a second. So that means kilowatt, right? 4.5, 32,300 divided by 3,300 will give you the answer in kilowatts, right? Simple, okay, it's not hard. Okay. 4.5 multiplied by 32,300, 3,600, right? 40.375 40.375. So let's say 40 point, okay, let's take it like that, 40.375 kilowatts, right? So that is the heat input. So what is the indicated thermal efficiency? So then indicated thermal efficiency will be what is the indicated power? 12.88 divided by 40.375 multiplied by 100%. Tell me what is the answer? 12.88 divided by 40.375 multiplied by 100, 31.9. 31.9, or let's say 40%, right? 40% indicated thermal efficiency, right? The next one is the easiest. Brake thermal efficiency. Very easy, right? Very easy. How to find that? That means the easiest, brake thermal efficiency, right? Now there are several ways, right? Brake thermal efficiency equals brake power divided by heat input into 100%, right? So what is brake power? We know that 10.179 divided by heat input. What was the answer? It was heat input is we already calculated in the previous step. That is 40.375 into 100%, right? Calculator, please. 10.179 40.375 25.21%, right?